Welcome to the sixth module, which is about the effects of the Industrial Revolution. Before the Industrial Revolution, the industries were mostly cottage industries with animals such as horses or bullocks, or humans providing the energy. Transport was by walking or horse and buggy. The Industrial Revolution brought steam trains and factories that burnt wood or coal to supply energy. This was later followed by petrol, diesel, gas, oil as energy sources, as well as the use of coal for much of the electricity generation. Practices of the Industrial Revolution greatly increased the carbon dioxide output into the atmosphere and increased the production of acid rain in many locations. Chlorofluorocarbons, which are known as CFCs, were originally chosen as a propellant for spray cans and as refrigerants in air conditioners because they are so inert and therefore will not react with other chemicals. As you know, your noble gases are your inert gases, right? On the right-hand side of the periodic table. The inertness of CFCs allows them to drift up to the stratosphere unchanged. In 1976, scientists discovered that there was a reduction in ozone above the Antarctic. They realized that chlorofluorocarbons and other halides were contributing to this reduction. The ozone is very important in the stratosphere as it reduces the amount of ultraviolet light that reaches the surface of the Earth. UV light is a major cause of skin cancer. Practices have been implemented to reduce the release of these gases into the atmosphere. So as you can see, our comforts, not just our comforts, but the way that the world has grown has indirectly affected, have directly affected the environment. So this topic is quite a large one. So this video will sort of try and touch on little bits and split them up into main themes, so greenhouse gases, greenhouse effect and global warming, ozone layer and depletion, and the acid rain. So the dot points in your syllabus don't exactly match up in the sequence that they appear. They kind of match up randomly. So make sure you are aware of this as you're going through the worksheet. So the regions that are most affected are the hydrosphere and the atmosphere. Since the Industrial Revolution, we've built huge cities all over the world whose large power demands must be met. The main way that we have achieved this is through the burning of fossil fuels. So let's have a look at greenhouse gases to begin with. So we have a few dot points about greenhouse gases. We have something about the composition of emissions. We have to gather and analyze a lot of information. And we also have to identify the origins of greenhouse gases and acid rain from both natural and man-made environments, okay? So let's go through this PowerPoint and hopefully you'll be able to match up with the dot points. So the burning of fossil fuels release energy and gases into the atmosphere which affect the chemical and physical properties of other atmospheric gases. We call these greenhouse gases. The main ones include carbon dioxide, water vapor, methane, fluorocarbons, and nitrous oxide. So if we have a look at the different, annually, the different kind of gases that are emitted by the different activities, human activities. For overall greenhouse gases, carbon dioxide, methane, and nitrous oxide. So we see nitrous oxide mainly comes from agricultural byproducts. We see the main one of carbon dioxide is power stations, and for methane it is between agricultural, which is not a surprise, and fossil fuel retrieval, processing and distribution. So you can see industrial processes and power stations are kind of in competition. Okay, so 16 and 21%, that's quite close to each other. So it's good to be aware of the types of activities that cause the most emissions of greenhouse gases. Obviously, it's a hot topic, so there's a lot of data available. Okay, so I've got a few graphics here which can just give you a different idea of the percentage. This is a percentage of the amount of the different types of gases, which are all obviously greenhouse gases. So the least being nitrous oxide. Okay. We also have a table that shows us, and you can look up these sources and see the most recent ones, and they tell us what the concentration is, as well as pre-industrial concentration, and then anthropogenic sources, so human-related activities, okay? So not natural. Because even though methane is a natural byproduct of animals, the amount of animals that we produce, the scale since the Industrial Revolution is huge. And not only that, but cutting down the trees to make space for those animals reduces the amount of trees there are which actually use carbon dioxide. So it's still a major contributing factor. Okay. Some more graphics just to show you. And this is showing us some of the. You can have a look at some data from volcanoes, okay, which kind of give us the more natural environment, natural sources, natural sources of carbon dioxide. And then we've got Australia. So having a look. So when you are doing this dot point, I just want you to make sure these are the ideas of things that you could be researching when you're gathering, processing, and presenting. Okay, so greenhouse gases are transparent to particular types of radiation, allowing some types to pass through them while absorbing others and preventing them from passing through. As you know, some radiation is harmful, some radiation is what heat is. If you remember your electromagnetic spectrum, this property of selective absorption of radiation is responsible for creating what is known as the greenhouse effect. The greenhouse effect is enhanced by increasing the levels of greenhouse gases in the atmosphere. All 5 of the following compounds are referred to as greenhouse gases because of their ability to selectively absorb infrared radiation from the Earth and allow radiation from the Sun to pass through. The table below shows the relative proportions of the main types of greenhouse gases, excluding water vapor. So mainly, as you saw in that graphic, 57% was carbon dioxide, 25% were fluorocarbons, methane 12, and nitrous oxide 6. This table shows the warming potential for each of the gases listed. Notice that the CFC is over 7,000 times the warming potential of carbon dioxide. According to the table, it may appear as though carbon dioxide plays an insignificant role in the greenhouse effect. However, due to the large quantities present compared to the other gases, it plays a major contributing factor in producing the greenhouse effect. So as you can see, we're looking at 2 different factors. Looking at the percentage, but we're also looking at the warming potential. So if we crunch the numbers, we can sort of come to this conclusion. So even though one may be have a much lower warming potential, together with the information, with the fact that how much carbon dioxide is in the environment, that's why it is probably the major contributor. The water vapor originates from one of the 2 following processes: evaporation from natural water storages and a byproduct of industrial processes. The combustion of coal is a process responsible for emitting water vapor into the atmosphere. Coal is responsible for producing, I think it's 76 to 77% of the electricity in Australia. Over 80% of carbon dioxide emissions is due to the burning of fossil fuels. Most of the remaining 20% is made up from the burning of forests that have been cleared. The concentration of CO2 is currently rising. Evidence from ice core samples suggests that before the Industrial Revolution in the 50s and for 10,000 years prior, carbon dioxide levels were 270 parts per million. Currently, the level is 350 parts per million and rising. The chart below shows by region the carbon dioxide emitted per capita. Where are we? We are second, Australia, Oceania. Don't forget that includes a lot of the Southeast Asian countries. as well, where they have highly populated cities. Most of our fuels contain carbon as they were formed by the decay of living material. The products produced from the burning of these fuels are primarily carbon monoxide, carbon dioxide, and water vapor. Not only does the burning of coal add water vapor to the air, it also adds high amounts of carbon. The carbon released by burning coal reacts with the oxygen to produce carbon dioxide. The combustion of octane in petrol in an automobile also adds significantly to the atmospheric carbon dioxide levels. Methane makes about 95% of natural gas composition. Before the Industrial Revolution, methane levels were about 750 parts per million. Today they are close to 1,650 parts per million. The rate is increasing about 1% each year. Sources of methane emissions include the following processes: naturally produced in swamps as a result of the breakdown of organic material, fermentation, which is part of some natural ecosystem cycles. Don't forget, guys, that's important too. Fermentation of grass in the stomach of animals, anaerobic decay in rice paddies, and emissions from mining and drilling programs. So what you should do, guys, before I go on, is if you want to, you have to analyze some data. First, you have to gather this kind of information. You can get them from some internet sites and some of the information that is presented to you here. Make sure that you do include information about natural processes such as these methane productions, and you have to think about any recent human events that have contributed to greenhouse gases or acid rain. Maybe have a look at the Environmental Protection Authority, EPA, or Greenpeace, the Total Environment Centre, or the Nature Conservation Council. You can have a look at their websites and their sources to see the kinds of local strategies that are in place for both natural and human-made sources of greenhouse gases, as well as acid rain, which we'll talk about soon. Also, what you have to do is gather information and process that show the information, the natural origin from the made environment, and if they are greenhouse gases. So make sure you have some sort of table in your notes that show where the sources are of carbon dioxide and other gases. So you might do one for carbon dioxide, methane, nitrous oxide, etc. And then after you've looked at the types of gases that are contributing to the greenhouse effect, then you can do another table for the strategies, which is in your notes anyway. So here we go. 90%. Cows and sheep are responsible for 90% of methane. So this is about 3 million tonnes every year. Other processes that produce methane include decomposition of livestock manure and the decomposition of landfill. This methane produced in landfills has proved to be a usable resource. In Melbourne, methane produced from decaying rubbish is being used to generate electricity. So, natural formation of nitrous oxide occurs through the action of certain bacteria on nitrogenous material in soils. Prior to the Industrial Revolution, atmospheric levels were 285 parts per billion. Today, they are at 305 parts per billion. Human activity has increased the release of nitrogen into the atmosphere through increased use of fertilizer. Nitrous oxide is also produced in automobile engines. Fluorocarbons are gases containing chlorine compounds made by humans. Prior to 1850, the atmosphere contained none whatsoever. The levels in 1990 were 0.00025. They are increasing at a rate of 4% each year. These are all the different types of fluorocarbons, HFCs and CFCs. Fluorocarbons were largely used as a refrigerant in air conditioners and refrigerators, as propellants in aerosol spray cans, and as solvents. Currently across the world, these are gases being phased out. And that's the end of part 1.